Hello everyone, welcome to PK Chemistry. In this video, I am going to solve previously appeared chemistry questions in KRTET. So the first question is, milk is an example of, first option is sol, gel, foam and emulsion. So this question comes from the colloid chapter, that is colloids chapter. The colloid is a heterogeneous system in which one substance is dispersed as very fine particles in another substance. So the dispersing substance is called as dispersed phase, and in which it is dispersing, that is called as dispersion medium. Based on the colloids can be distinguished based on the nature of dispersed phase and the dispersed medium. First one is, when the dispersed phase is solid, this is dispersing in the solid medium. This type of colloid is called a solid sol. The examples are colored glasses and gemstones. These are the examples. These are the colored glasses and gemstones are the solid sols. When the solid, that is dispersed phase, is in the dispersion medium is liquid. When the solid is dispersing in the liquid, the type of colloid is called as sol. The examples are paints, cell fluids are the examples of sols. When the solid is the dispersed phase and is dispersing in the gas, this type of colloid is called as aerosol. The smoke dusts are the aerosols. These are smoke and dust are the examples of aerosols where the dispersed phase is solid and the dispersed medium is gas. When the dispersed phase is liquid and dispersed medium is solid, then the type of colloid is called as gel. Cheese, butter, jellies are the examples of gels. This is a type of colloid. When the both dispersed phase and the dispersed medium are liquid, then the type of colloid is called as emulsion. Milk, hair cream are the examples of emulsions. This is the type, emulsion is a type of colloid where dispersed phase and dispersed medium both are liquids. And when the dispersed phase is liquid and dispersed medium is gas, it is aerosol. This is also called as aerosol. And fog, mist, cloud, insecticide sprays are called as aerosols. And when the gas, that is dispersed phase is gas and dispersed medium is solid, then these are called as solid sols. Pumice, stone, foam, rubber are the examples of solid sols. When the dispersed phase is gas and it is dispersing in the liquid medium, then the type of colloid is called as foam. Froth, whipped cream, soap, lather are the examples of foams. Hence here milk is an example of, comes under emulsion where the dispersed phase and dispersed medium are both are liquids. Hence option 4 is correct. That is, milk is an example of emulsion. Next question is, polyester among the following is, options are PET, neoprene, Bunayan and nylon 66. This question is from polymer unit. Polymers are the macromolecules where the monomer units combine to form the macromolecules are called as polymers. Means monomer means single molecules or single units. When the single units or the single molecules combined to form the macromolecules are called as polymers. And polymers are classified based on the structure and source and the type of polymerization. And the type of polymerization classified into addition polymerization and condensation polymerization. Here the condensation polymerization is also called as step growth polymerization. These are the 4 different polymers are there in the condensation polymerizations. These are classified based on the after the condensation of 2 monomer units, which is the linkage molecule between the 2 monomer units. Here the first one is polyamides. Amide is the linkage between 2 monomer units to form the polymer. Hence these are called as polyamides. Polymers possessing amide linkages are termed, and these are also commonly called as nylons. Nylon 66 and nylon 6 are the examples of these polyamides. And condensation of diamides with carboxylic acid going to give the polyamides, and amino acids with their lactams combined, polycondensation of amino acids and their lactams going to give the polyamides. Next one, polyesters. Here the polycondensation of dicarboxylic acids and diols to form the polyesters. Here the ester is the linkage between two monomer units to form the polymers. Hence these are called as polyesters. And dacron or pterylene is the good example of polyester. Here ethylene glycol and the terephthalic acid. Ethylene glycol means it is having two alcohol units. Terephthalic acid having two COH groups. Hence the COH group and the alcohol group combined condensation between the alcohol and the acid group to form the ester, linkage between these two monomer units. Hence the ester is the linkage between two monomer units. Like this, the condensation of this dicarboxylic acid and the diol to form the polymer, these are called as polyesters. Next one is phenol formaldehyde polymer. Here the polycondensation, this is the polycondensation products of phenol and the formaldehyde. The example is bakelite. And next one is melamine and melamine formaldehyde polymer. This is the polycondensation between melamine and formaldehyde. And the example is melamine polymer. Here they have given the four options: PET, neoprene, bunion and nylon 66. Here you got to know that nylon 66 is polyamide, because here there is a amide linkage is there between the two dicarboxylic acids and the two amine groups. Hence this is nylon 66 having amide linkage. Hence these are comes under polyamides. And nylon 6 is polymerization of caprolactam. Caprolactam undergo polymerization to form the nylon 6. Hence this is comes under polyamide. And PET is a polyester. PET is a polyester. PET is also called as polyethylene terephthalate. It is, and also polycaprolactone, PCl, PBT, PTT, PLA, polylactic acid. These are the examples of these polyesters. And neoprene is a synthetic rubber produced by polymerization of chloroprene. And bunion is also a synthetic rubber, and it is copolymer of 1,3-butadiene and acrylonitrile. Hence option 1 is correct, that is PET. PET is a polyester. These are the examples of other polyesters. Next question is, a number of elements are available in the Earth's crust, but most abundant metallic elements are. Means many number of elements are available in the Earth crust, and abundant, meaning of abundant means higher quantity. Which are the higher quantity metallic elements are there in the Earth crust? So here they are, the options are aluminum and copper, second in aluminum and iron, copper and silver, and fourth one is iron and copper. So these are the four options. Here you can see that these are the top 10 elements which are present in the Earth crust. The first higher abundant element is oxygen. Oxygen is the 46.1% is in the Earth crust. And next one is silicon. And next one is aluminum, iron, calcium, sodium, like that. These are the elements. But they have asked the metallic element. The metallic element is aluminum. Aluminum is the most abundant metallic element which is present in the Earth crust, and this is the third most abundant element. First abundant element is oxygen, then silicon, then aluminum. But the first abundant metallic element is aluminum, then iron. This is also metal, hence this is the second most abundant element. And aluminum bauxite is the ore of aluminum, and hematite, magnetite, siderite and iron pyrites are the ores of iron. Means we can extract the aluminum by bauxite ore, and we can get the iron by the extraction of hematite, magnetite, siderite or iron pyrites. These are the ores of iron. Bauxite is the ore of aluminum. Here aluminum and the iron are the most abundant metallic elements which are present in the earth crust. Next question is monomers of dacron are. Means dacron is a polymer here. What are the monomer units of dacron? Here we have seen in the earlier question that dacron is also called as terylene. It is a polyester. Means the ester is the linkage between the two monomer units to form this dacron, that is terylene. And the formation of polyester, we need alcohols and the two acid groups, dicarboxylic acids and the diols to form combined or condensation to form the polyesters. Here the polymer from adipic acid and glycerol. Polymer formed from adipic acid and glycerol is a polyglycerol adipate, that is PGA. It is a type of biodegradable aliphatic polyester. And terylene or dacron is formed by the polycondensation of ethylene glycol and terephthalic acid. Means the terephthalic acid containing two carboxylic acids and ethylene glycol having two alcohol units. Condensation between this terephthalic acid and ethylene glycol to form the ester linkage. Hence this is called as polyester. Dacron is a polyester type of polymer. Hence the option 2 is correct, that is ethylene glycol and terephthalic acid. And next one, terephthalic acid and phenol. There is no common polymer is there by the linkage of the terephthalic acid and phenol, but bakelite is formed by the polymerization of phenol and formaldehyde. When the phenol and formaldehyde combined, polymerization takes place between phenol and formaldehyde to form the bakelite, as bakelite is a polymer. And caprolactam and ethylene glycol, this is the fourth option. There is no common polymer between the combination there is no common polymer formed by the combination of caprolactam and the ethylene glycol, but caprolactam is a monomer unit of nylon 6. When the caprolactam is heated about 543 Kelvin in the presence of water, then the nylon 6 polymer will be formed. Here the option 2 is correct, that is ethylene glycol and terephthalic acid. Next question is a peptide bond is formed when the carboxyl group of one amino reacts with another. Means the peptide bond is formed when the carboxyl group of one amino acid reacts with another group. The amino acid means the amino acid containing both carboxylic group and the amino group, because the carboxylic acid, that is COOH of one amino acid group, reacts with NH2 of the another amino acid, so that the H2O goes out to form the CONH2. That CONH2 is a amide group, that is a peptide bond. See here, the proteins are the polymers of alpha amino acids and they are connected to each other by peptide bond. Peptide bond is also called as peptide linkage. The peptide linkage is a amide bond. Amide means CONH2. Sorry, CONH. CONH is the amide group or the peptide linkage that is formed between the reaction between the COH group and NH2 group. Here they have given carboxylic group of one amino acid, means this is the COH is the of one amino acid, and they are asking about which is the another group. Another group is NH2, that is amino group. Hence option 4 is correct. Next question is sucrose is a disaccharide made up of. Options are glucose plus galactose, glucose plus glucose, glucose plus mannose, and glucose plus fructose. Means disaccharide means when the two monosaccharide units combine to form a disaccharide. First we shall understand what are this question is from the carbohydrates. What are carbohydrates? Carbohydrates are the optically active polyhydroxyaldehydes or ketones or the compounds which produce such type of molecules upon hydrolysis. These are called as carbohydrates, and carbohydrates are divided into three classes: monosaccharides, oligosaccharides and the polysaccharides. Monosaccharides means we cannot be hydrolyzed. We cannot further hydrolyze these units, means these are the single units. We cannot hydrolyze it further. So that these are called as monosaccharides. Glucose, fructose and ribose are the examples of monosaccharides. And next one is oligosaccharides. These oligosaccharides yield the 2 to 10 monosaccharide units upon hydrolysis. Means when you hydrolyze these oligosaccharides, you are going to get the 2, 3 like that up to 10 monosaccharide units. So that again these oligosaccharides are divided into 9 classes. Those are disaccharides, trisaccharides, tetrasaccharides and up to 10 in monomer units. Disaccharides means when you hydrolyze the disaccharides, you are going to get the 2 monosaccharide units. Means 2 monosaccharide units combined to form a disaccharides. The examples are sucrose, maltose and lactose. In the sucrose is the disaccharide. In the sucrose, glucose and fructose are the 2 monosaccharide units. These glucose and fructose combine to form a disaccharide, that is called as sucrose. And in the maltose, glucose and glucose, 2 glucose units combine to form the disaccharide, that is known as maltose. And in the lactose, glucose and galactose are combined to form the lactose. So these are the disaccharide units. Here they have asked the sucrose. So the sucrose is a combination of glucose and fructose. Hence option 4 is correct, that is glucose and fructose. And next one is polysaccharides. Polysaccharides are there are large number of monosaccharide units are combined. Means more than 10 monosaccharide units are combined to form the this carbohydrates. Those are called as polysaccharide units. And these are combined, these are linked, the oligosaccharides as well as the polysaccharides are linked through the glycosidic linkage. And the examples of polysaccharides are starch, cellulose, glycogen and gums and etc. So these are the examples of polysaccharides. So the option here, the sucrose is a disaccharide made up of glucose and fructose. And glucose and galactose, lactose is combination of glucose and galactose, and the 2 glucose units combined to form the maltose, and there is no such combination between glucose and mannose, and this is not a disaccharide. Option 4 is correct, that is sucrose is a combination of glucose and fructose. Option 4 is correct. Okay, thank you.